Okay, this is the lesson on electric fields. Last lesson you should have looked at electric or static charge and some of the uses of static electricity. Today we're just going to look at what is an electric field. This ties into our work, which we will be doing on magnetism later in the course, and we're going to look at the dangers of static electricity and talking about the idea of charging and discharging. Okay, but first, what is a field? Is it one of these? It's not really, is it? A field in physics is an area where a force is exerted on particular items or objects. So we know from last lesson that charged objects, if the object is charged, then it will exert a force on another charged objects. They don't have to be touching, they do this from a distance. Okay, so we know an electric field would be the area where a charged object feels a force, and it would not have to be touching the thing that is causing that force. Okay, and that area we would call an electric field. So something that is charged has an electric field around it, and any object that is also charged that's put into that area will feel a force, and that area is what we call, or what we mean by, as the electric field. Alright, so if you're positively charged, this means that electrons are going to have been removed. So if you imagine if this metal sphere is positively charged, so let's just make a note, we can see there it's positively charged, that means it's got less electrons than it should have, so electrons have been removed. Okay, now if we drew the field lines on this, they would look like that. They would radiate out from the charged object perpendicular to the surface at 90 degrees to the surface, and they become straight out. Now these lines would show, they all point away from the surface, and what they show is they show that the force, or they show the direction of the force that would be on a positive charge. So if this is a positively charged sphere, if I bring a positive charge in, they will repel. So the positive charge that I bring in would be moved or forced away from the charged metal sphere. So that's the direction of the arrows. The direction of the arrows is pointing that way because it shows the direction of force on a positive charge. So if we look at a negatively charged metal sphere, so with a negatively charged metal sphere, this is where it's got more electrons, so you can see I've left the electrons on, so it's got an excess of electrons. In this case, the field lines would point towards the surface of the sphere, and that's because a positive charge brought in would feel an attractive force towards the charged metal sphere. And remember, the arrows or the direction of the field lines is based on what a positive charge would experience or feel. So they show the force that will be put on a positive charge. Okay, so just make sure you've got the basics. An electric field is the area around a charged object. In this area, another charged particle or other charged particles will feel a force. They will either be attracted or repelled. The force between two charged particles will increase as the distance between them decreases. So as we get closer to these objects, the positive charge, in the first one here, the positive charge would feel a stronger force of attraction. In this one, the positive charge would feel a stronger force of repulsion as we got closer or reduced the distance. So just make sure you can sort of explain those. Okay, in the lesson you might have used the Van de Graaff generator. Sometimes it appears on exams. How does it work? Well, you don't need to know really too much in depth, but you might have noticed when you used it, there's some kind of a plastic roller with a rubber, like big rubber band connected between them. So there's a friction. Remember last lesson we talked about how friction causes a transfer of electrons. So this friction between the rubber band and the rollers transfers electrons from a sort of a power supply at the bottom where there is an excess of electrons, and all these electrons end up on the top metal surface, otherwise known as a collecting sphere. Now when you come close to that, all of these electrons are repelling each other. They are desperate to get off the surface, so if you come close enough with either your hand or another metal object, then what can happen is that the Van de Graaff discharges through the air, and the charge is so great that the air itself conducts, and that's when a spark occurs, and the spark is when the air conducts and you get a discharge, and that's the thing that hurts when you're on the Van de Graaff, which you might have experienced in the lesson. Alright, so the key idea with the Van de Graaff, it's a way of charging something, but what you do need to understand is how static electricity discharge can potentially be dangerous because it can cause sparks. Okay, so that's the thing to realise from the Van de Graaff lesson. So what causes the spark in a static discharge? So we've said electrons that have built up on the top dome or the top metal surface of the Van de Graaff, they all repel each other. When a conductor comes near, there is enough force to cause them to jump through the air and flow to Earth. You might have picked that up from your study of what we mean by Earth in terms of your study of household electricity. So they flow to Earth, they jump through the air through you or through the metal conductor and discharges the Van de Graaff. This colliding of electrons and air molecules causes a release of energy that we see as a spark. So just really to finish, can you explain why your hair stands up on the Van de Graaff? Well, if you put your hand on the Van de Graaff, there's going to be electrons coming off the Van de Graaff all over your body, all over all your hairs. So all of your hairs have the same charge, a negative charge. So the hair will repel your body will repel your hair, so your hair sticks up. And then dangers of static. If you've ever been on an aeroplane, they might have got people to get off the plane. They should have done to get off the plane when it's being refueled. This is because that the fuel flowing along a pipe, the fuel pipe, can actually cause a static charge build-up on the aeroplane. And of course you can imagine if you've got lots of fuel around, aviation fuel, which is highly explosive, and you've got the potential for sparks, then you've got the potential for explosions and fires. So you do get static electricity causing problems when sparks can start fires or explosions. So make sure you know the dangers as well as the uses of static electricity, and also how the Van de Graaff helps us to explain this.